In our last video, we talked about standardizing data so that we can work with a standard normal curve when finding percents. The reason behind this was because finding the area under a normal curve can be tricky, but other people have done all of the work for us and found the area under a normal curve where the mean is 0 and the standard deviation is 1. That just leaves for us transforming our data points into points on the standard normal curve. These points on the standard normal curve are called the z-scores. What we're going to do in this video is look at some points that we had already standardized in our last video and use the standard normal table to look up the percent of data that is to the left of that z-score. You can also use the simulation that's in our book, but the book will not be open to you during a test. So it's good that you have practice with the standard normal table because you will be allowed to use that on the test. If you recall the study from our last video, in 1973, a study was done by the CDC. It found that 12-year-old boys had a mean height of 151.1 centimeters with a standard deviation of 8.18 centimeters. The question we began with was, what percent of boys in 1973 were less than 145 centimeters in height? The first step was to standardize the data. So we are standardizing the value of 145 centimeters based on a mean of 151.1 centimeters and a standard deviation of 8.18. We plugged it into this standardization formula. The z-score is equal to the data value minus the mean over the standard deviation, or z equals x minus mu all over sigma. For this problem, we found the z-score to be negative 0.75, which means it's right about here. And we're going to be finding all of the data to the left. The standard normal table is a way for us to look up z-scores with 2 decimal places and determine the percent of data that is to the left of that z-score. If we look at a standard normal table, you'll see the first column has got the ones place and the first decimal place, so the tenths place for our z-score. And then the column has the last decimal place, or the hundredths place, for our z-score. If we had a z-score of negative 3.92, the negative 3.9 we could find in this column, and then the hundredths place is the 2, so this 0.00004 would be the percent of data that is to the left of negative 3.92. In our particular problem, the z-score was negative 0.75. So in this column, we're going to look for negative 0.7. Which we see right here. And then each row gives us the hundredths place. So this would be negative 0.70, negative 0.71, negative 0.72, negative 0.73, negative 0.74, and negative 0.75. That's the one we're looking for. This is the area under the normal curve that is to the left of the z-score, negative 0.75. So we can say the area to the left of z equals negative 0.75 is 0.22663. Now remember, the entire area under the curve is 1. The area of everything under here, all of this is equal to 1. And in specific, the area to the left of 0.75 is equal to 0.22663. If we want to convert this to decimal form, we would take this number and multiply by 100%, and that would give us 22.663%. This means that 22.663% of the data is to the left of the z-score, negative 0.75. And in terms of this problem, That means 22.663% of the 12-year-old boys were less than 145 centimeters. The next question we're going to do is similar. This one I asked, what percent of boys in 1973 were more than 168 centimeters tall? We standardized this in the last video, and we got the z-score to be 1.09. So the z-score that we found is here. And since I'm asking for the percent who were more than 160 centimeters tall, I'm asking for this. We can use the standard normal table. The standard normal table will give us all of this. Since all of this is the area that the standard normal table gives us, and since the entire area under the curve is 1, I can find the area that I want by doing 1 minus the area that the standard normal table gives us. Let's go back to the standard normal table, look up z equals 1.09, and find out what area that gives us. 1.09, that's positive, so we'll scroll down. Here's 1.0, 1.00, 1.01, all the way to the end, which is 1.09. So the value that we get from the standard normal table is 0.86214. This tells us that the area to the left of our z-score, 1.09, is 0.86214. This leaves us to find the area that we want by doing 1 minus 0.8624. We put this into our calculator, and that gives us 0.13786. This is the area to the right of our z-score, 1.09. Now we can turn this into a percent to interpret it in terms of our original problem. 0.13786 is equivalent to 13.786%, and this is the percent of data that is above a z-score of 1.09. It's also the percent of 12-year-olds who were more than 160 centimeters tall.